Okay, so now I'm going to go ahead and go through a whole new presentation of building a numerical spreadsheet example because I accidentally left the microphone off on the last one. So let's go ahead and say we have two different goods, apples and bananas. And our first step, of course, when the Bureau of Labor Statistics does its research, is to figure out what the market basket of the two different goods is. And let's suppose, well, you know what, that doesn't reflect my personal preference. I would rather have us eating more apples and fewer bananas, because bananas are just kind of bland. Okay, and let's suppose that apples are going to be $3 a pound, and bananas are going to be $2 a pound. Then how much do people initially spend on apples in the base year? Because we're going to go ahead and make the year where we measure our basket our base year. They spend $60 on apples and $20 on bananas. So the total cost of the basket, of course, is the amount they spend on apples plus the amount they spend on bananas. And then in our later years, prices are going to change, but the basket does not. So I'm just going to go ahead and keep those basket quantities the same. But then prices are going to change. $5.25 using Excel, so there's no reason to keep two nice round numbers. Okay, and we're going to go back now and compute how much they would have had to spend to buy all their apples and how much they would have had to spend to buy all their bananas. And then we're going to compute how much they would have had to spend to buy their overall market basket as time goes on. And the CPI is 100 times how much it costs to buy the basket in the year we're interested in measuring, divided by how much it costs to buy the basket in the base year. Now for the base year, those two are the same number, so we're going to go ahead and just get 100 back when we do this. For later years, they're not going to be the same number, and when you copy a formula in Excel, it often tries to automatically guess what equivalent cells you could be referencing here. I'm going to go ahead and tell it to not adjust the bottom of this fraction when I copy it. So I'm going to put that $sign in there, and that'll keep it from changing the row number when I copy the formula. So there's a little Excel tip for the day. And I'm going to go ahead and copy this down here and paste it. And let's just double check that it did what I wanted. Yes, it did. It's doing 100 times this cell over that cell, and that's exactly what I want. And here, it's doing the same thing, this cell over that cell. Okay, so our CPI has gone from 100 to 131.25 to 171.875. The inflation rate is the percentage change in the price level. And we can go ahead and do this the hard way, which is going to be the new value minus the old value over the old value. And Excel thinks this is a percent, I believe. So we want to tell it that it's a normal number. Okay, so 31.25%. Now I would actually go ahead and instead not multiply by 100 and just we're going to tell Excel that this is a percent. So it comes out as a decimal. We'll tell Excel that it's a percent. Or if we're really, really wanting to be lazy / efficient, it's also true that we can compute a percent as new value divided by old value minus 100 and skip ourselves a little bit of math there, and then tell Excel that's a percent. Anyways, all of those are equally valid ways to compute a percent. And we can go ahead and do the same kind of calculation for the amount of inflation that happened between 2010 and 2011. And we go ahead and get that it was 31% again, though it's slightly different here. It's slightly less than 31%, and there it was slightly more. Okay, so that is how we go ahead and use our data to compute the CPI in different years, and how we use the CPI to go ahead and compute the inflation rate. So, as follow-up from that, you should be able to go look at changes in the CPI and figure out what the inflation rate is. And then a couple of last things before I go through here. We can go ahead and split the CPI into different subsets. So in particular, we could look at it for particular goods. We could look for particular geographic areas, of particular metropolitan statistical areas. And if you were sort of interested in knowing, am I better off making $40,000 a year in Sacramento or $50,000 a year in San Francisco? Well, you know that the cost of living in San Francisco is higher. Is that extra $10,000 enough to compensate you for the fact that the cost of living in San Francisco is higher than Sacramento? Well, you would use the CPI calculations for the different geographic areas to do that. We could even potentially look at the CPI for particular demographic groups, because different demographic groups have different market baskets, different average consumption patterns. And then we could also look, not usually something that most of us are directly interested in, but we could look at the producer price index. So the consumer price index measures the price of things that are typically bought by consumers. The producer price index measures the price of things that are bought by producers, suppliers. This is most often looked at as a predictor of future consumer price inflation, because if the prices that producers are paying are going up, then it's likely that they will attempt to pass along those price increases in the near future to consumers. Let me just go back to this medical CPI for a second here. And often people sort of say, well, you know, medical costs are going up by blah percent per year. And it's, you know, something huge like 8 or 10% or something like that, which is much above the normal rate of inflation. And that's actually a little bit of a misstatement. I think it would be more accurate to say that medical spending is going up by, say, 8 or 10% per year, far faster than the rate of inflation. But what's happening, of course, is that all the time, new and better medical procedures and drugs and machines and so on and so forth are created. And those new and better things are more expensive. At the same time, our country's getting older, and so older people generally consume more medical care than younger people. So if we actually look at what happens with the price of particular drugs or procedures, we see that the medical CPI, the price of medical goods and services, tracks pretty well with general price inflation. This red line is the rate of inflation for things out there in the economy as a whole. This gray line here is what's going on with medical goods and services. You can see that there was a time here in the late 80s through the sort of middle 90s where medical inflation was significantly higher. And maybe you can sort of go, okay, here in the late 50s, there was also another period. But the differences more recently are pretty darn close together. We're sort of talking, you know, the difference between, say, 4% and 2%, or 4% and 3%, or something like that. So most of the growth in medical spending isn't that medical prices per se are going up faster than general prices. It's that we're consuming more technologically advanced and more expensive medical treatments, and that our population's getting older.